Hey guys, it's Mr. Marone. Welcome back. Today we're going to talk about measuring segments. So we're going to take what we learned in the previous lesson, specifically regarding segments and pieces of lines, if you remember, and we're going to look at how to measure them. So the first thing we have to talk about is what's called the ruler postulate. If you remember from yesterday's or today's lesson, the ruler postulate or any postulate is something that does not need to be proven. It can be just accepted as a mathematical truth. So here's our first one that is new for this section. It's called the ruler postulate. And it says that every point on a line can be paired with a real number. And we refer to those, if we think back to Algebra 1, we had real numbers in our graphs, and we refer to them as coordinates within a coordinate plane. Here they're not going to have 2 points like we did on a coordinate plane. It's just going to be one value. And the ruler postulate allows us to find the distance between those 2 points. And what's really key is that it's always going to be positive. So if we look over here on the right hand side, we've got point A and point B. They're in capital letters, and the coordinates of them would be in lowercase letters below the number, or above it depending on the graph, but in this case they'll be below. And if you see on your screen here, the measurement of segment AB is going to be the coordinate of A minus the coordinate of B. But it's inside these absolute value bars. So it's always going to be positive. We can't have a negative distance. You can't have negative 5 feet. So just always keep that in mind as you're doing answers and doing problems, that you can't have negative measurements. So if we look at this example, they gave us 4 points on a number line, and they want to know what's the measurement of ST, segment ST, and the measurement of segment SV. So ST, if we use that formula that we saw on last page, segment ST is the absolute value of -4 minus 8. And that's going to give us, -4 minus 8 gives us the absolute value of -12. And absolute value turns everything positive, so our distance is 12 there. We have no units, so it's just 12 units. For SV, same thing. So SV is going to be equal to the absolute value of -4 minus 14. And when we do that, we get the absolute value of -18, which turns positive to 18. Now, when we put this into practice, we have this first piece, which is called the segment addition postulate. And that tells me that if I have 3 points that are collinear, they all sit on the same line. In this case, we have A, B, and C. And if point B sits between A and C, we see there that this segment over here, AB, plus this piece BC is equal to the whole thing AC. So in other words, if I told you that AB was 5 and BC was 7, with segment addition, by using our formula over here, 5 plus 7 is going to tell me that AC equals 12. Obviously, that's a very simple example, and we're going to do something a little bit more difficult with it, tie in our algebra skills to it. But that's the basics of segment addition postulate, that the 2 smaller pieces that create a full segment are going to be equal to the measure of that segment. And once again, you cannot have negative measures. So looking at this example, they gave us that EF equaled 8x minus 14, and that FG was 4x plus 1. And they told us over here in our information that EG equaled 59. So if we were to set this up using our segment addition postulate from the last page, we know that EF plus FG equals EG. And if I plug in my information here, I've got 8x minus 14 plus 4x plus 1 equals 59. Combining like terms, I have an 8x here and a positive 4x here, so I get 12x there. Minus 14 plus 1 is going to give me minus 13, and that equals 59. I'm then going to add 13 to both sides, and I get 12x equals 72. And to finish it up, when I divide by 12, I get that x equals 6. Now, in algebra, most people would stop right there. X equals 6, great, got our answer. They asked for EF and FG. So we have to plug back in. EF equals 8 times 6 minus 14, which is 48 minus 14, which gives me 34 for segment EF. And for FG, we have two options. We could plug back in, which we'll do here. So we've got 4 times 6 plus 1, which gives me 24 plus 1, or 25. My other option was that I could have just subtracted 34 from 59 to get that remaining piece there. We take a look at one other example, and this would be a good point in the video. If you want to pause this and work this on your own prior to me solving it, that would be a good idea. But we've got JK plus KL equals JL. And plugging in, I've got 4x plus 6 plus 7x plus 15 equals 120. Combining like terms, I have 11x plus 21 equals 120. And when I subtract 21, I get 11x equals 99. And when I divide by 11, x equals 9. Once again, they asked for JK and KL. So I've got 4 times 9 plus 6 to get JK. And that gives me 36 plus 6 more, which is 42 for JK. And we'll do a plug back in again for this. So we've got KL equals 7 times 9 plus 15. So I get 7 times 9 is 63, plus 15 more gets me 78 for segment KL. Now, the last piece we're going to talk about is an idea called congruent segments. So when two expressions have the same exact value, we say that they're equal. We say that x equals 4, that 7 equals 7. We use an equal sign there. When we're talking about segments, when two segments have the same length, we say that they're congruent. So the big difference here, what you really need to keep in mind, is when you're given measures, actual numbers, we say that they're equal. But when we're talking about just the segments themselves with no value, then we use congruence, as you see here. On the left-hand side, AB and CD both had a measure of 1 inch, so we say that those segments are equal to each other. But over here we have this one tick mark right here. That's an indication of congruence. And when we don't have values but we have these tick marks, then we can say the two segments are congruent. And our symbol for congruence, because mathematicians are lazy, as you guys know, is an equal sign with the squiggly line above it. So we have congruence when they don't give us measures, but they give us a tick mark or some other indicator telling us that the segments themselves are the same. Where over here we have their measurements are the same, and that's where the equal sign comes into play. Make sure to fill out the Google form, finish out your last name, your class period, and answer the questions, and make sure that you submit it prior to coming into class on Monday. Have a great weekend, guys.